I'm going to show you how to use Leipzig and Overtone to create a new track from scratch. And as you can see, from scratch means creating the project itself. Now we've got a standard Clojure project, and we need to add our dependencies. So we're obviously going to use Overtone, which at the time of writing was at 0.91, and we're going to use Leipzig, which is at 0.8.0. Once we've got those, we can start a REPL. Now if you hadn't already brought down those dependencies, then lein would do that for you now, but I already have. So now I have the REPL, I'm going to start Vim in a new tab. Other editors are available, obviously, but I really enjoy using Vim Fireplace to make music. I find it a very agile environment. So we're connected to our REPL actually. So we can, for example, execute commands we see here, and we'll get instant feedback, which is how we're going to generate our music. So first of all, let's require Overtone into this namespace. So this is requiring overtone.live, and I've just executed that namespace, and I've got a little bit of a wait, which is to allow the synth server to be started up. If I want to make sounds, then what I need is Overtone to run the Super Collider synth server in the background and pass my instruments and my invocations of those instruments to that synth server. Right, so it's started up now, so we can create an instrument now. So we'll create a bass, which will default to 110 Hertz if we don't pass it a frequency. And we'll use a saw wave, and then use an envelope to shape the sound. So an envelope is what prevents the sound from just droning on forever. It gives the start and the end of it. So it's going to be a percussive envelope, and we want to free the synth at the end of this envelope, which just means that we don't want to leave a whole bunch of synths around. Right, so hear that sound? I think we can actually make this a bit more interesting. Let's use a resonant low pass filter, and we'll have it descend from, I don't know, times frequency, 10 times the frequency, to the frequency itself over 1 second. So we get just a little bit of a different sound. That's muted, and we can also kind of hear the resonant low pass filter descending with an ow sound. Cool. Alright, so let's find something interesting for our bass to play. So this is just a simple phrase, hitting the root note and then the fifth. I'm going to execute that, and looks like we can't yet because the double macro doesn't let us execute things until we've applied functions to them. So let's do that. Let's put the pitch in a particular key. And by that I mean, for example, a minor. Now we can't find where because we haven't imported anything from Leipzig yet. So let's do that. Leipzig melody is what we need. And we also need Leipzig scale. So if we execute the whole file, we find that we have our track, which is just 2 notes, which have a pitch expressed in MIDI as it happens, and time and duration expressed in beats. Now we need to do a little bit more work before we'll be able to reasonably play these. So let's play these in equal temperament. Obviously we'll need that. That namespace as well. And that means that our track is now in hertz. Now we also need to do something about the time and the duration. Now this where function is nothing magical, it's just performing an update in on the relevant key for every note in the melody. And our track is 2 notes, but time and duration are in seconds now. The last thing we need to do is we need to tell Leipzig what it means to play a note of a certain part. So play note is a multi-method. I'm going to say the default part. How should I play it? Well, what I need to do is I need to get the pitch. So we destructure the hertz from every note, and we just invoke that bass on the appropriate hertz. So if we evaluate the namespace again, we find we don't have live. So that's a separate namespace, Leipzig live. And now we do have it. So we should be able to play the track. There we go, let's play it again. Alright, that's reasonably musical. In fact, let's loop that while we do further investigations on it. So I'm going to call the jam function, live jam, on the var of track. And the reason I call it on the var is so that the function can repeatedly dereference the argument and loop things. So that's actually a little bit high for bass. So let's lower it. Twice. So we're lowering it 2 octaves. In other words, we're subtracting 14 MIDI from it. Probably easier to start extracting this into separate defs. And putting things in like this. Reevaluate, and there should be no change. Right, let's do something a bit more interesting. Alright, so let's do a little bit more interesting things with the bass. So that's the bass line just going around repeatedly on the same root note around the same chord. So what we actually want to do is a 12-bar blues, which goes root chord, third, root chord, fourth, root chord. So we want to find a way to repeat this bass line over the chords we want to play. So there's a function called map then, which is an analog of mapcat, which we can apply to our progression. But of course we need bassline to be a function. So we want to know, we want to start at the root each time. Wrong number of args passed to where? master where? We can see the problem is that our double arrow comprehension has excluded the second where. So let's pull it in again and reevaluate. Right, so we're going to hit the root note once and again. Now hopefully going to walk up to the fourth. There we go. Alright, and then back to the root. Alright, that's pretty cool. And that's going to just keep looping, so we better define some other interesting things to do with it. So I'm going to define a kick, which is basically a bass drum. And that's going to be composed of two frequencies, one that stays steady and one that drops. So the one that drops is going to drop from the frequency to half the frequency. And we're going to say, well, let's say we do it over half a second. So we're going to sine oscillate that, and then we're actually going to add in the second sine wave at the base frequency itself. And we need to multiply this by an envelope. So let's just try how this sounds. Let's try our kick. And again. Actually sounds quite good, I think. So let's define a beat so we can include that into our track. And that beat is going to be another phrase. And phrase takes durations then pitches. So the durations are going to be actually half the ones of the bass rhythm, interestingly enough. So that's actually only going to take up 2 beats. And the frequency, and there's a reason why we're going to do this with the frequency, but we're actually going to do a frequency of -14, which will tune our drum relative to the root note of our key. And we're going to set the part to be beat. So it's a bunch of, well, something's gone wrong there. Well, looks like I've just evaluated an infinite sequence, which is a bad idea. If you see, I've got repeat the 14 here, and I've got this cycling forever. So what I actually wanted to do was take 10 notes from it, and that means that it'll be nice and finite and just loop that twice. In fact, 10 notes is 4, so let's say we'll get 8 beats if we take 20 notes. Let me try evaluating again, which should start up the server again. So that's actually something that's a little bit of a danger, obviously, with working with the REPL in general, is that you might find that you've killed your REPL by accidentally evaluating an infinite sequence. And though while an infinite baseline makes conceptual sense, it doesn't make sense to bind it to a var. Alright, so let's try now with this beat, which we take 20. Alright, so it's 20 notes. And notice we've actually put a part for them. This is so that we can use the play note multi method to define how to play a beat. Let's just let's start by starting the track again. actually going to, for the beat, do something very similar. We're gonna kick at the hertz. Alright, so we want the beat to go along with everything else. And it sounds quite good. In fact, we probably want it to do it 6 times because now it's faded out again because we only played it once. It sounded a little bit loud though, to be honest. So I'm going to quieten it. Whoops, that's the bass. I'm going to quieten the bass drum a little bit. Whoops, I said take here. What I wanted to do was times 6, which is a Leipzig melody function. Now if we look at beat, well, we've got a lot of beats. But that's the beauty of using code and Leipzig to generate the beats, that we can algorithmically specify a lot more beats than would be convenient for us to put down by hand. Alright, let's get another instrument. Let's define an organ, which will have duration as well. So we'll start with a frequency, then we'll get a saw wave. Now we want to have an envelope for this as well. Let's see if I can get this right. An ADSR. Want an InfGen. We want to free the envelope when we're finished. We also want to use a line from 1 to 0 over duration in order to kick in when the ADSR is finished. Alright, that's a little bit harsh, but it's kind of cool. Let's shape it with another resonant low-pass filter. And let's actually make the filter itself sine oscillate. Let's say it 3 times a second. And what we want to do is we want the filter to start at a certain point in the frequency spectrum, and we want it to wave up and down by a certain amount. So we're going to multiply that sine signal, let's say by 300. That means it's going to cover a range of 600. And we're going to start it at, let's say like times 4 the frequency. Let's hear it again. Alright, and that's a nice spacey sound. We can make it more sophisticated in a bit, but let's get it on the track first. So let's say the part, let's call it the accompaniment, because that's a little bit more logical than just the chords. It shows the role the piece of music's playing, not kind of what it is. And so we want to play the organ. But with the organ, if you see, we actually need the duration as well. So let's match that as well. Alright. Now we need to define a part, and this is okay, I guess, to call the accompaniment. And this is going to be composed of a phrase of repeating of 8 notes. Well, actually, probably we want the accompaniment to repeat 8 note and to be a chord, triad, chord, root, So what I'm doing here is actually saying the accompaniment should take an argument, so we can map it in the same way as we did the bass line. So it should be a single phrase of a chord for 8 beats. That's just a triad with a certain root, and then what we're going to do is we're going to mark it as being in the accompaniment. So for example, if we do accompaniment of 4, sorry, I haven't included the chord namespace yet. Now I have, reevaluate. So now if I go accompaniment of 4, it's playing a chord with the root note at 4. So now I can do something a bit clever, much like for bass line. And add that accompaniment in as well. So if I look at the track, I've got a lot of notes, but there are things there from the beat, from the accompaniment, and from the bass. So when we next cycle round, we should get something that includes our organ, and we're going to be able to start refining our organ sound so it works to our advantage. And alright, so I just quietened it. Let's quieten it again. So the reason it's so loud is partly because it's actually playing multiple notes at once. Just adding a few more resonant low pass filters. You might notice that whenever I change the organ, it's actually changing it live, so it doesn't have to wait for the new loop, it's changing as the instrument is called. Let's mess with this envelope a little bit. So ADSR has a tack of... Alright. So we can make this a little bit more percussive. Let's make the sustain a little bit lower. So this is really, I guess, working quite well as a track. Let's mess a little bit with it just to get a few different sounds, and then we can put the track to bed. Let's make the bass sound a little bit more like an acoustic bass. If you want to hear it, let's get rid of the chords for a second. I actually want to make the drums a little bit different, because they're just the same drum over and over again, which is a little bit boring. Alright, so the next time round, hopefully, the beat should sound a little bit different because each drum on the offbeat is actually an octave higher, so we should get an interesting kind of overlap effect. And on the fifth, back to the root, and come on. Alright, so it's a little bit cheesy, but you can feel the upper drum happening. So let's bring the organ back in. We can start to mess with that again as well. The organ, let's make that a little bit interesting. So what we're going to do is we're going to multiply it by a square wave so the organ will cut in and out for an interesting effect. I quite like that actually. Get some interesting effects by just varying the speed at which the organ comes in. Right? But instead of playing just the chords just as chords, let's see if we can do some arpeggios, because that will sound quite good. So actually the sequence of things that we want to do is that, we want to take the values in the chord and cycle through them over and over again. So it's not actually defined at the moment, but any order of arpeggio will actually be quite nice. And let's make it 7th chord just so that we have 4 notes in each cycle round. So I actually want to repeat 8 single notes now. So in the end what we should get is just some interesting arpeggios. Alright, so we're getting some interesting interplays of rhythm and frequencies. Alright, let's just go straight back to the plain beat. And so I'm going to finish off the track by defining the track var to be nil, so that the var, the jam that is repeatedly dereferencing it, knows to stop playing. Second last. Last 2 bars. Right, and that was Leipzig from scratch. So that shows how to build up a track from literally nothing using Leipzig and Overtone. That might not have been quite enough or slow enough to have you repeat it, but that should at least show you each stage that's necessary in making a quite realistic and fully fledged track with Overtone. Thanks very much.